This circuit shows an Arduino-controlled motor driver system using an L298N motor drivers module, a DC motor, and a potentiometer for speed control. The L298N module controls the motor speed and direction, powered by a battery pack connected to the module's input terminals. The DC motor is connected to the outputs of the L298N module, out 1 and out 2, while the Arduino Uno sends control signals to the module via the digital pins. The potentiometer is wired to one of the Arduino's analog input pins to act as a variable resistor. As the potentiometer is rotated, it changes to the voltage sent to the analog pin, which the Arduino reads to adjust the motor speed using PWM, pulse width modulation. This PWM signals is sent from one of the Arduino's PMW enable pins to L298 module and a pin, controlling the motor speed. The in1 and in2 pins of the motor driver are also connected to Arduino's digital pin to control the motor's direction. This code demonstrates how to control a motor speed and direction using a potentiometer and the L298N motor driver module. The setup defines control pins for two motors, motor pin 1 and motor pin 4. For speed control using PWM signals and motor pin 2 and motor pin 3 for direction control. The potentiometer is connected to analog pin A0 to measure user input, which is then used to adjust the motor behavior dynamically. In setup function, the motor pins are configured as outputs and serial communication is initialized for debugging purpose. The loop function starts by regarding potentiometer value, which range from 0 to 1023, and then maps it to a motor speed value to between 0 to 255. This scaling ensures potentiometer full range can control the motor speed. The motor operation depends on the potentiometer value. If the value below is a threshold less than the stop motor function is called to stop the motor by setting the speed to 0 and halting both directions. If the motor was previously stopped but the potentiometer value increased above the threshold, the motor resumes operation. When the motor is running, the direction is controlled based on the potentiometer value. If the value is less than 512, the motor rotates forward clockwise with motor pin 2 set high and motor pin 3 set low. The value above the 512, the motor rotates backward counterclockwise with the pin state reversed. Meanwhile, the motor speed is set using analog write on the PWM pins motor pin 1 and motor pin 4. Lastly, the code provides debugging information by printing the potentiometer value, motor speed, and the motor state, running or stop via a serial monitor. This feedback helps monitor the system behavior in a real time. A small delay ensures stable operation between loops. The overall structure ensures seamless control of the motor speed and direction based on user input from the potentiometer.
Analog I/O and motor control systems are essential for enabling precise and dynamic interactions between electronic devices and their environment. Analog inputs, like sensors or potentiometers, allow systems to read continuous data, such as speed, temperature, or position, enabling real-time adjustments. Motor control systems, on the other hand, use this input to regulate motor speed, direction, and torque, making them vital in automation, robotics, and industrial applications. Together, they enhance system efficiency, flexibility, and accuracy, ensuring seamless control in tasks ranging from simple household appliances to complex machinery.